Math 103, section 6.4 and 6.5. So I already talked about the density curve and histogram that we are using for discrete variables. Here, this is some examples that you see it on Roxy-Peck textbook, the one that you have on WebAssign. And for instance, here it shows you that if you want to find the probability of less than 1.5, means you have to find this area of this triangle. Area of this triangle is the base multiplied by the height. Height is the probability, which is 0.75. So 0.75 times 1.5 divided by 2, which gives you the probability of x less than 0.5. And if you want to find probability of x greater than 1.5, then all I need to do is take these and subtract it from the entire triangle, from the big ones. All right, so we take this and subtract it from 1 because we know the probability is always 1 for the big ones. So if you take this piece out of that, that gives you these small ones. And this shows also another examples here that how you calculate this rectangle and this rectangle. So in case of density curve or in case of rectangle, as I mentioned, is not that hard to do it because all you need to do is just do some geometry and find the area of either here a rectangle or a triangle. But when it comes to continuous, when it comes to the curve, then we cannot really do the calculations by taking area of rectangle because now you see there is a curve here. And the example is like here. How do I find probability between 0.75 and 25, this area? Or how do I find probability of x less than 0.75 is just the entire area. This is a small one, 0.25 is very small. So we show you how to do the calculation for that. Now, when we explained the probability distribution, we mentioned that one of the conditions of probability distribution is that before we actually do it, we want to make sure that some of the probability is always 1, which is in this case. These problems, we cannot work on this problem because the sum is not 1. See, sum of xpx is 0.66 in this. Sum of the px is 0.66. It's not 0.1. Okay, so in that case, probability of sum of the probability is not 1. So this is not a probability distribution table. So again, probability distribution table, sum of px must always be 1. This is another examples that look at the x. X has to be a discrete number. So this table violates the first requirement because x is not a numerical random variable. So in this case, because of the x value is not numerical value, this is not probability distribution table. So I'll show you some examples how you could tell whether it is or not. And then for the probability distribution table, there are two formulas. One is to calculate the mean and one is to calculate the standard deviation. Since it wasn't very clear here, I'll show you on the next page. So if we give you a probability distribution table and we ask you to find the standard deviation, there are two formulas to use. One is this and this is the second one. This one, in fact, is in Roxy-Peck. On your textbook, they are talking about this one, but I felt that maybe it's easier to use this. In my case, I like this more than that one. But I'll show you on the next page on the examples. What is variance? Variance is when you take a square standard deviation and raise it to power of 2 is the variance. So if you take a square root of the variance, then it's a standard deviation. So a standard deviation, what's the difference between a standard deviation and the variance? Variance is what you have under the radical is your variance. So when you find the standard deviations, and if you ask you to find the variance, variance is what you have under the radical. This is another example of the density. Remember, this is a rectangle and this is here. When you have a discrete, these are all discrete because it's whole number, okay? So probability is given for each value of x. Now, if the question is find the probability of x greater than 2, how do I find probability x greater than 2? Probability x greater than 2 means you need to find this shaded area. How do I find the shaded area? Means you find area of this rectangle, which is probability of x equal 2. You find the area of this rectangle, which is probability of x equal 3, and add together, okay? If we ask you to find the mean, again, mean is sum of xpx, but we don't use it here. How do I find probability of x less than 3? Make sure we adjust this a little bit. How do I find probability of x less than equal to 3? Less than equal to 3 means all of this. See, probability is the entire area of all 4 rectangles. That's how you find it. You go all the way from 3 to 0. Now, this is another example I put it here. It's got a practical example for you to see where we use this probability distribution table. A score of 10 students in a stat class are listed below. When we ask you to find a mean, I want to show you, 2 different methods how to calculate a mean. In case you have a single numbers and we ask you to find a mean, all you need to do is add all these numbers and divide by 10. Why? Because there are 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for you to calculate average or the mean, all you need to do is find sum of all this, divide by n. That's one way to do it. Or we could use this formula. But if you want to use this formula, then here, how many 7 do we have here? 1, 2. So frequency is number of times that one item is repeated. This is the frequency. So how many 70 do I have? 2. How many 78? 1. 80, I have 380, is that right? 1, 2, 3, yes. So you list all your numbers here and how many times each is repeated. And sum of f, which is sum of this, is 10. Because there are 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so to use this formula is x times px, means you need to create a new column. This column is taking the value of x and multiply by px. Like the first one, x is 70 and px is 0.2. So if I take px, which is 0.2, and multiply by 70, I get 14. Second one, px. X is 78 and is 1 when you multiply this 78. When you add all these numbers, that gives you the mean. See, you come up with the same value here. So there are 2 ways to do the mean. One is you just have all the numbers listed and find it through this formula, or some of the numbers are repeated. So you just put like, I have 2 of the 70, I have 3 of 80, I have 2 of 90, and so on, and you find it. Now, a standard deviation is from this formula. To find the standard deviations, you have x2 px, means you need to create a new column, which is x2 px. You already have xpx, which is 14. If I take xpx and multiply by x, if you take this and multiply by that gives you x2 px. So to find x2 px, you take this 14 and multiply by 70. To find 608.4, you take xpx, which is 7.8, multiply that by 78. 78 times 7.8. Now at the end, if you find sum of xpx, if you find sum of x2 px, which is this numbers, then you put it back here, minus mean to power of 2, which we already find it. That's how to find the standard deviations. So this is a formula for the mean. This is for standard deviation. They're here in this example, they're just asking you to find the mean, which normally, sometimes we say XPX or YP, it doesn't matter what letter you're using. Like here, instead of X, they're using Y. It's the same thing. So sum of Y has to be 1. But here, I'm sorry, probability, the sum of the probability has to be 1. But you have to calculate sum of XPX or sum of YPY, which is points that give you the value of mean. That's how to find the mean from this formula. But before I do that, first I have to check to make sure it is probability distribution. See, you know why I did this? To make sure that this is a probability distribution table. Because if probability distribution table, sum of all this probability has to always be 1 before we actually continue. These problems, probability distribution is given, okay? 0.2 plus 0.5, 0.7 is 1. They ask us to find mean and standard deviation. Mean is the sum of XPX, okay? Then you just take this, multiply that plus this time that, plus this time that. Now, for a standard deviation, I show you 2 methods. One method, which is this formula from Roxy-Perks, and the other formula, which I put it there. I show you how to calculate a standard deviation using both formulas. You should come up with the same value here. Okay, depend which one you like to use. You know, when you have this, when you have the standard curve or normal distribution curve, there are 3 important points on this. The middle of the graph is always mean. But if you take mean and add 1 standard deviation to it, or if you take the mean and subtract 1 standard deviation, you get these 2 points. If you take a mean and add 2 standard deviation, you get this point. If you take a mean and subtract 2 standard deviation, you come over here. When you get almost close to the tails, there are 2 tails, 1 here, 1 there. When you get close to that, then mean plus 3 standard deviation and mean minus 3 standard deviation, you find. In some of the problem, we ask you to find sum of mean plus or minus standard deviation, or mean plus or 2 standard deviation, or 3 standard deviation. That's why I put this example here so you could see it. Okay. Like in this one, mean is given, a standard deviation is given. If you want to find mean plus 2 standard deviation, that's how to find it. Like this is an example that they ask you to do it. See, this table is given, right? First, they want you to find the mean. They want you to find the variance and the standard deviation. Remember, variance is what you have under the radical. And here, see, the reason they put a standard deviation to power of 2 means this is the variance. And then they ask you to find mean plus 1 standard deviations and mean minus 2 standard deviation. It's kind of a small here, but you actually have the copy of this so you could see it. So they want us to find, see, you already find mean and standard deviation here, right? You find mean and standard deviation. Then you have to find mean plus or minus a standard deviation, or 1, mean plus or minus 2 standard deviations. So you take the standard deviation and add or subtract to mean. Here you take the standard deviations, you take a standard deviation multiplied by 2, then plus or minus mean. And these problems are all really very similar. I put this solution for you. Now, how do I calculate the area of the curve? Like here, Z, a standard curve. Remember, a standard curve is a special case that mean is always 0 and standard deviation 1. There is one particular curve which standard deviation is always 1 and mean is 0. They call it the standard curve. Based on the standard curve, you come up with some tables. These tables are designed based on that. So and then a standard curve, the horizontal axis, we call it Z. If they ask us to find probability of Z less than 1.27, see, this is 0. And the standard curve is the normal one. And mean is in the middle, you have mean, which is 0, right? But if you go 1, 2, 3, 1, 2, 3, since a standard deviation is 1 and mean is 0, what is mean plus or minus standard deviations? Is 0 plus or minus 1, or just plus or minus. What is mean plus or minus 2 standard deviations? Mean is 0 plus or minus 2 times 1, right? So it's 2 plus or minus 2 plus or minus 1. And what is mean plus or minus 3 standard deviations is plus or minus 3. So on the standard curve, 1 is here, 2 is here, and 3 is there. Minus 1, minus 2, and minus 3. So when we ask you to find Z of less than 1.27, and this is Z, right? It doesn't have to be exact, but 1.27, let's say somewhere here, right? This is 1.27. Less than that means from here to the left. They want us to find this area. Okay? Let's say we say find Z less than minus like 2.5, something like that, right? This is Z. Let's say minus 2.5 is here, roughly. They want us to find this area. Or let's say they want us to find Z is greater than 2.7, correct? So let's say 2.7 is here somewhere. Greater than that means they want us to find this area. Table always give you area to the left. Table always give you area from that number to the left. So if you want to find the area to the right, what you need to do is first, for the number that given the problems, from the table you find this area, then subtract from 1. Why? Because the total area under each curve is always 1. So if we ask you, for instance, in this one, Z is greater than, if they ask us to find this area, find this area from the table first and then subtract from 1. And I'll show it here how to do it. But, you know, going through the table and find the area takes time, but I'll show you later on how to use the calculator and find the area, which is way, way easier than this. Okay, all right, so let's see here. These are the table. One table is for the negative numbers and one is for positive numbers. Let me see if I can find the table. And I think I have a copy of this table online for you on the Canvas. You know, this is where you have all the formulas. And these are the table that we normally use. But if you know how to use the calculator, then we don't need the table. This is for the negatives. And then see how you show the left side is for the negative. This is all the positive Z. These are the positive number. Okay, examples. Let's say they ask us to find Z less than 2.8. Now I want to, so what you do is, when they say 2.08, you take the the very first number before the decimal, you find that here. And then after the decimal, you find 2 digits. You find that at the top of the table, and that gives you the area of 0.9812. Okay, so for 2.08, the whole number is here. The decimal part is on the top. Now, I want to use the calculator for that. Calculator, you could use the second VAR's normal CDF. Calculator always require a boundary, means it wants 2 points. Okay, you have one side, you have this point, but you don't have that. Since the numbers here is always -1, -2, and -3. -3 is almost close to the tails, end of the tail, right? We use the arbitrary numbers of like -10, large number. In that case, you know the graph would touch at that point. So this number is an arbitrary number. You could always use it for the problem. Again, because this normal CDF or calculator require both end. You have one end, the other end, you could just put -10. See? And that gives you the answers. When you do it this way, it gives you this 0.9812. What if you ask to find Z greater than 2.08? What if they ask us to find this area, right? See, if you want to use the table has to find this area and then subtract from 1, okay? So you could do that, or if you want to use the calculator, see how easy it is in the calculator. Since calculator needs 2 end, one end is 2.08. What about the end here? Put +10. This is an arbitrary number. So if you want to use the calculator, you go to normal CDF, like what we have in the top. And for Z1 and Z2, put 2.08, and here put +10. Or if you want to use the tables, you have to find this area from the table first, which is that, right? Then subtract from 1. Why? Because the total area is 1, and if you take this, subtract that, give you the shaded one. Calculator is very handy for a problem like this. Look, Z is between these two numbers, means they want us to find this area. This is easier because calculator always require both endpoints. So when you put normal CDF, Z1 is -2.13, comma, Z2 is 1.53. The calculator would give you this area. Z greater than -1.75. The picture is just for you to get some idea. It doesn't have to be exactly -1.75 here or there, it doesn't matter. Greater than -1.75. Again, we need both points, right? 1 point is given. For the other point, just use 10, arbitrary number of 10. That gives you this area. So not understanding that, then you could do all these problems. Now I'll show you that if you want to use TI-84, when you go to the second VAR's normal CDF, you just have a lower, upper, stuff like that. If you use TI-84 plus silver, then you have to put Z1 in the parentheses. It's not like this format. It's Z1, comma, Z2. Okay? So for instance, let me show you for this one. Let's say this one. Find the area between -5 and 5. Well, this is almost 1. Why? Because here, look. If this is 1, 2, 3, 5 is probably somewhere here with it, okay? And -5 is here. So basically, is the total area, which is the total area under the curve, is always 1. So that's not a very good one to use for Z between 5 and -5, because it's the whole thing. How about this one? Z between -2.23 and 0.54. So -2.23 and 0.54. Okay, let's look at this. They want us to calculate this, right? They want us to find this area. Find the probability that Z is between these two numbers, 0.54 and minus 2.23. So we said we were using what? Second VARS normal CDF. Second, and this is VARS. You see the VARS? Because below, under that is distribution. Second VARS is normal CDF. I don't know if you could see it or not. Lower one is minus 2.23, and the upper one is 0.54. And a standard deviation for a standard, when you see a Z, a standard deviation is always 1 and mean is 0. Remember, mean is 0, standard deviation is 1. And I calculated for you one more. It gave you 0.69. 0.69 is your 0.69 is your area for this one. Okay. All right, so you should be able to do all these problems using the calculator for these. Now, sometimes you don't deal with Z, you actually dealing with X, the real numbers in probability. In that case, you cannot use those tables anymore unless you convert X to Z, convert X to Z from this formula. I have it here. For instance, if you say find probability of X greater than like 20, is X, is not Z, right? So you have to do the conversions. This is in case you don't have a standard curve anymore. A standard curve is a curve that mean is 0 and the standard deviation is 1, right? But you're dealing now with some curves that are not a standard, like this one, look, mean is 69 and standard deviation is 2.8, or the other one, mean is 63.6 and the standard deviation is 2.5. So in that case, you have a normal curve. And how do I find the area of the normal curve? What you need to do is, if you want to use the table, you do need to do the conversion of X. You already have mean and standard deviation, right? You put those here and you put the X there to find the Z, and then you continue. That's why I show you this picture here so you could see it. See? It's not very clear here, but it wants to show you that if you want to go from mean and X to a standard curve, which is 0 and Z, you have to use that formula. It's not very clear, but it's just a formula that I'll show you. For instance, this one. Find the probability of X greater than 72. See, this is a real problem. Height of men's are normally distributed with mean of 68.6 and a standard deviation of 2.8. See, right here, since the mean and the standard deviations are not 0 and 1, then this is not a standard curve, it's just a normal curve. See, that's why the mean is 68. So in that case, when they ask you to find and then the horizontal axis is not Z anymore, it's the X. Horizontal axis is X, is not Z anymore. So what I need to do is I need to convert this X to the Z. When you want to do the conversions, then this Z, I have a better one here, look. So what you need to do is you have to do the conversions from this formula. If it's population and a sample, sometimes problem they are dealing with samples and population, both are the same formula. But here, look, we want to find probability of X greater than 72. X is 72, mean is given is 68.6 and the standard deviation 2 point. These are given, right? So you have to put all in this formula to change it to Z. Now, instead of saying x greater than 72, you just say z greater than 1.21. Both have the same area. So here, you want to find probability of z greater than 1.21, means this one. If you want to use the calculator, then you just say, again, normal CDF, Z1 and Z2. Z1 is 1.21. What should I use for the other side? 10, right? Or one of the advantage of calculator is, if you want to use a calculator, you don't even have to go to change up from X to Z. You could use the same normal CDF, but here, since mean and the standard deviation is not 0 and 1, you could actually put 4 numbers here and the calculator will give you the answers. Put X1, 72. X2, what number should I use for X2? This is a very large number. Again, this is an arbitrary number, 1,000. Mean is given in the problems. A standard deviation. If you put all these 4 numbers, then you have the area. So you don't need to even do the conversions. Look at this one. First, I want to show you how to convert it to Z. There are 2 conversions here. These are the x's, right? X1 and X2. You have to convert that first to Z1, convert that to Z2. And then now you have probability of Z between these 2 numbers, right? Or you could use your calculator. You don't have to go through all these. Put X1, X2, mean standard deviations, okay? X1, X2, mean standard calculator would give you the area that you want. X1, X2, mean standard deviation calculator will give you the area. All right, so now understand this is another. Sometimes we give you the area and we find the x. I don't think so we have a problem like that on your homework, but I just threw that here just in case. Means if you already have the area and we ask you to find the original x, how does that work? If we give you area already, means you're doing it backward. So in that case, in this formula, the z value, you have to find the z value. How do I find the z value? From the table, if you have 0.95, then your z on the table is 1.645. You take that and you put it here. That would, when you do cross multiplication, that gives you the value of x. But again, they don't have that problems on your homework, but just for your information. All right, so doing that, now you should be able to do all these problems. See, like here, they say find the probability that x is less than 60, right? And the mean and the standard deviations are given the problems. Suppose the word is 60 minutes for typical using a split keyboard can be for normal. Mean is 60, see, a standard deviation is 15. Mean is 60, a standard deviation is 15, means this is just a normal curve, which mean is 60 and the standard deviation is 15. And the first one, they want to find the probability that probability of x is at most 60, means is equal to less than 60. They want you to calculate that, okay, which I'll show you here. Again, if you want to use a calculator, look, x1 and x2, okay, for, I think this is for that, this is for this one. For this one, if you want to use a calculator for your x1, put like 0, and for x2, put 60, okay? So for, in case of x, you know how we said for the z, if you have the area, for instance here, let's say this is like minus 2.7, use like minus 10, or if the area is here, use positive 10. For the x, here is always 0 on the left. So if you say find x, I don't know, let's say mean is 60 and we find the probability of x is less than 63, right? Which is here, in this area. What should you use for X1 and X2? 0 and 63, okay? But if the area for the X, they ask us to find this, then if this is like 70, what should I use on this side? Just use a number, I'll go like 1,000. Because for the X, you always start from 0 and number increase to like 1,000 or whatever. So you should be able to do all these problems using those formula. And there is a solution here. So it's a good practice for you to use the calculator to see if you have all these numbers, okay? All right, so that would be the end of this one, which is a little bit longer than the other tapes.